All right. Hey, everybody. I'm making the video for Lab 6 here, which is going to be glacial landforms. This is the last lab that we're going to have of the quarter. And it's about glacial landforms, which I think Andy has already talked to everybody about. So let's get started. I'm going to talk about different types of glacial landforms, and then we'll talk about the lab a little bit. So we're going to be talking about alpine glaciers, which are glaciers in the mountains, and this is in contrast to continental ice sheet type of glaciers that were, around in the Ice Age, and we're not going to be talking about those in this lab. So an alpine glacier occupies a valley and flows down a slope, and they modify the landscape. And they do in two ways. They cause erosional landforms when they carve and erode bedrock material, and they cause depositional landforms when they relocate and deposit the eroded material from the erosional process. Moraines are a specific landform produced by deposition of glacial sediments, also known as till. There are several moraine types. There's terminal, medial, lateral, end moraine, and the ground moraine. And I'm going to show you everybody some pictures of these different types. So, as we can see, I'll start with the end moraine. The end moraine is the moraine at the end of the glacier that's farthest down the valley. There will often be several terminal moraines. Every moraine at the end of the glacier is a terminal moraine, but only one end moraine. And the reason for that is that climate change it's warming since the Ice Age, and that's taken a long time to warm up. And so the glacier has existed at different lengths throughout time. And lately it's been getting smaller. So you'd have, some Ice Age ones, and then some middle ones, and then now. And you'd have different moraines for each of those. So that's why the terminal moraine is not always the end moraine. There might be multiple terminal moraines. Lateral moraines are moraines that are on the sides of glaciers. And medial moraines are when there's multiple glaciers flowing into each other, and then they, instead of flowing together like a river and mixing, they have a moraine between them, and that's a medial moraine. And remember, these are all depositional features, which means that they're basically stacks of little rocks in contrast to solid cliffs. So and that's characteristic of a depositional feature. And in your lab this week, basically, normally we'd have you play with some paper maps, but instead this week, since everything is online, we're going to be using Google Earth for the whole thing. So we're going to be looking at a lot of different Google Earth moraines, and here's an example of a moraine in Google Earth where you guys are going to be looking. So this is in the Sierras, the Sierra Nevadas in California, and we can see here's this valley, and on the outside of the valley there's these piles of sediment here, and those are old moraines, and there used to be a glacier that ran down here. But the Ice Age ended, and it's retreated up. That's in contrast to this is also a pile of sediment we can see here. But instead of being a moraine, this is an alluvial fan, and it was made by a river. So this shape is distinctively glacial. Basically, this diagram here is showing the different types of erosional features that are possible. And the basic one is the arête, I think. And the arête is when there's two valleys that are coming down that each have a glacier in them. And glaciers are eroding on either side, and when they erode together like that, they have a knife edge, and that's called an arête, which is a French word. It's important to note that rivers only erode the bottom of the valley because they flow to the bottom, and they form V-shaped valleys, whereas glaciers erode both the bottom and the sides, creating U-shaped valleys. You can see the U here, and also all of these are U-shaped. U-shaped valleys have steeper sidewalls than a V-shaped valley. You can kind of imagine that if you're a spatial person. Otherwise, there's some pictures too. But that's what makes arêtes extra sharp. And then when multiple arêtes go together, that makes a horn. And the point where a glacier flows from is called the cirque, and they're bowl-shaped. Some other things is the truncated spur is when, so this looks like a alluvial landform carved by rivers mostly, and you can see that it got cut off by the main glacier. So that would be an example of that. And then also can cause hanging valleys, like this. So these are actual pictures of erosional features instead of a cartoon, where you can see the U-shaped valley here in the arêtes, and more U-shaped valleys. This is a U-shaped valley. This has a glacier in it, so you can't see the bottom. And this is a characteristic V-shaped valley, so you can see that V shape in it. And here's a close-up of an arête. Here's a person and a dog hanging out down here, for scale, so they're pretty big, right? And so there'd be a cirque over here and a cirque over here. Yeah, and arêtes are pretty cool to climb up on. Angel Pass Wind River Range. A horn. Here's a real picture of a horn where multiple arêtes come together. This one is extra dramatic. It doesn't have to be this dramatic to be a horn. This one over here may be a horn. It just has to be 3 or more cirques eroding together. Okay. Head wall, cirque, arête. Here's some pictures of arêtes here. These are both arêtes. And then this is the head wall, which is the back of the cirque. This is this bowl here. And tarns are lakes that form inside bedrock erosions from a previous glacier. So there used to be a glacier here. These look like old cirques. And when the glaciers melt, they've carved bowls in the bedrock, and these are perfect spots for new lakes to form. And you can usually tell if it's a tarn by this nice color too. They have a really nice blue color, and that's because when you have finely ground rock in your water, it turns it really blue like that. And when you go hiking around Mount Baker, like in the Alpine zone, there's a lot of tarns up there, so you might have seen them before if you're a hiker person. And Paternoster lakes are a series of glacial lakes. You can imagine the glacier that used to live in here went all the way down, and it carved these bowls because glaciers tend to have this like kind of loop-de-loop pattern, so they do this. And it's called a Paternoster lake because a German monk was hanging out and looking at him, and he decided they looked like a rosary. And Paternoster is German for Our Father, so that's how you can remember that. It's because it's like it's like a bead, like a chain of beads, sort of, is the idea. And this is a picture of a map with a cirque and a tarn. A cirque lake is a tarn, right? But we're not going to be using actual maps, so I'm just going to skip this. All right. So yeah, instead of the Maps lab, it's going to be Google Earth, and Andy has created this new lab on Canvas just for you. So that's pretty cool, and it's actually really nice. He's got like really nice directions on here. So it's basically Just read it and go, adventure. Um, so, if you remember, you can go to Google Earth, and I'll just refresh you on some things you can do in here. So, like this first question, it says fly to Mount Tom, California. So, remember, all we have to do is go into the search bar because we don't know where that is, right? So, Mount Tom, California. Came up. And we're going to go there. And it's in the Sierras because the Sierras are like pretty pretty good example for like glacial landforms, right? And then we just read the question. So like the question is like, the topography of the map area is complex with exceptional relief. Relief is like the difference between the height of the tops of the mountains and like what's below them. So a lot of that difference. And this is due to tremendous tectonic uplift between Round Valley and the Sierra Nevada. A mega eruption just 20 miles north of the map. The action of the valley glaciers modified the mountain regions. So basically, he's asking for the elevation of Round Valley and Mount Tom. So Mount Tom's right here. And if we put our mouse over it in the bottom right corner, you can get the elevation, which here would be 4,145 meters. Your Google Earth might tell you that in feet. Either one's okay. And then we're going to look at Round Valley to see the difference. Here's Round Valley. So we put our mouse over there, and this is 1,429. If I wrote those down, then I could just subtract them from each other to get the relief. Yeah, I think I'm going to just show you guys what a river carved valley looks like here, and then just point out some arêtes, and then a horn or two to kind of like get everybody primed here. But I think that box directions are really nice, so you won't have any trouble. So this is a river carved valley. We see that? See how it's V-shaped? And it's really cool. If we actually look, we can see how V-shaped it is if we do this. I'm going to make a transect. That's pretty V-shaped. You see that how the slopes pretty linear? Boop, boop. So that's definitely carved by a river. Whereas if we go to this valley here, where Sheelite is, let's do it here. And we're going to probably get a U-shape because this is definitely carved by a glacier. We'll do this. Okay, see the U? So you see this flat, it's got this long flat bottom here, and it goes up. So that's the kind of the flat bottom is what we're looking for here. If we, oh, oh, I'm in the mountain. What's going on? And that happens sometimes, just like get back to where you're going. So cool. That's kind of what a U-shaped valley looks like. I know that this one is like a little bit VE too, but it's got the wider bottom to it as well. And do we find another example of a U-shaped valley? Here's more moraines. You see these moraines coming out? So if we looked at this one, we could do a transect here. Oh, this looks like a good example too. This is a really cool area. If anybody wants to, this is always a nice spring break destination. Although, it's kind of a long drive for that, for a week. Okay, check this out. It's U-shaped too with the long flat bottom here. So that's kind of the difference. Okay, I'm going to X out of that. And then we can look at some cirques. This is bountiful amount of cirques here. So here's a pretty good example. So this is a cirque here that doesn't have a glacier in it anymore. It has a lake in it. So that's a tarn. And you can just kind of see that bowl shape with the head wall in the back. Here's a good, see this cirque? This is a good example of it. So here's the head wall. Here's, this one also has a little tarn going on right here. Some cool steam coming out. And these knife edge arêtes here. It's really cool. Let's try to find some horns. How about that? Here's an example. This is a horn right here because we've got glacial activity over here and right here. And this is a cirque too. So I would call this one. And you might notice that it's like not as spiky as like the Matterhorn or something like that, but I would still consider that one. Here's another horn right here. Cirque, cirque, cirque. So kind of all over the place. Here's some good cirques with big head walls. Here's 3 in a row. You can see even from Google Earth how broken up the rock is that's being deposited. So these are the depositional features compared to the erosional features, which are cliffs. They're nice and hard and they won't come apart. Cool. I think that's pretty much it. I'll just show you really quick how to do the measurement tool. Yeah, here we go. And that's how you measure something. If you want it in kilometers or not inches, miles. Okay. I think everybody's gonna be good to go on this one. I don't think we'll have any trouble. Yeah. Okay.